In this video, we're going to talk about SLIs, SLOs, and SLAs. Well, why are we talking about this? Well, this is all about measuring the reliability and performance of your system. If you're building a distributed system, usually it's because you either want to build a system that is more reliable than a single centralized system, or that performs better. If you don't measure how well you're doing, you'll never know whether you've achieved this goal or not. So if we're going to measure reliability and performance, we need a vocabulary. We need common words which are understood by other people in order to describe how well we're doing. So that brings us to SLIs, SLOs, and SLAs. An SLI is what we're measuring. It's a service level indicator. An example of this is uptime. We might measure how often it is that when a user goes to a service, they successfully are able to get done what they ask to get done. It might be performance. It might be we measure how long it takes for a query to get a response generated by our system. An SLO is a service level objective. It's how well do we want to do on the SLI. We might set a target for uptime. We might say 99% of the time when a user goes to our service, we want to actually successfully give them an answer. Or it might be a performance objective. We might say 99% of the time we want the user to get an answer in under 500 milliseconds. Now, an SLO is useful for us as engineers to set a target, but it's not useful for customers because if they just know what your SLO is, they'll say, so what? That's your goal. What are you going to do if you miss it? And that's what an SLA is. An SLA is an SLO plus consequences. What happens if you miss that goal? The consequences could be severe. You could promise to your customers that if your system doesn't perform as described, doesn't meet its SLO, then you will pay for all of the lost revenue that your customers suffer. That's a pretty extreme SLA. The consequences might be more like a slap on the hand. You might promise your customers, if we meet our SLO, I'll write you a really apologetic email and I'll describe exactly what went wrong and what we're going to do to make sure that that never happens ever again. In either case, those are both SLAs because there are consequences to what happens when you miss your objectives. And a TLA, well, a TLA is a three-letter acronym. I have to apologize, this talk is full of them. So why are we studying SLIs, SLOs, and SLAs? Well, as we've already mentioned, the first thing is if you can measure it, you can improve it. And if you don't measure it, it's really hard to improve it because you don't know whether you're getting better or worse as you change your system. The second reason to study this is because unless you measure it, it's really difficult to learn what matters. And if you don't know what matters in your system, you might be wasting your time improving parts of your system that won't improve the things you care about. Or you might be building a system that is much more robust than you actually need to achieve your goals. Also, you want SLAs because when you're dealing with other engineers or customers, you want to be able to make them promises. That's a part of business. And if you don't have something concrete to promise them, they never know how much they should trust you or how much they should rely upon you. So speaking of customers, what if you're a customer of a service provider and you want to know how to read their SLA? Their SLA might be simple. It might say something like, I promise 99% uptime. Now on its face, that sounds like a good SLA, but it's incomplete. It doesn't give you enough information to really evaluate whether or not they've hit their goal. For example, they need to tell you how often do they check if their system is up. Hopefully they have an automated prober that is checking, am I up now? Am I up now? And you need to know the sampling frequency. Are they checking once a second, once a minute, once an hour, once a day? What does it mean to be up? In other words, what domain of responsibility are they assuming? Are they measuring it based from the edge of their network to their system and back out to the edge of their network? In which case, any problem between their network and your computers can cause you to go down and it's not their problem under the SLA? Or are they giving you a full end-to-end guarantee? It's good to know exactly where their responsibility ends and your responsibility picks up. Over what time interval are they promising a 99% uptime? Are they promising that for every second, 99% of that second it'll be up? Every minute, every hour, every day, every month, every year? Typically, when this promise is made, it's based on a monthly billing cycle. And so 99% of the time over 1 month would be what they're promising. And so what exactly does that mean? Let's look more into it. Usually we express this in terms of the number of nines. 90% would be 1 9. And that means that over a monthly billing cycle, 3 days of every month, they could be down and still be within their SLA. How about 2 9s, 99%? That's 7 hours a month they could be down and still be hitting their targets. So 99% uptime, 7-hour downtime, that might be pretty bad depending on when those 7 hours happen to happen. If they happen in the middle of a critical time when you're getting most of your sales, you don't want 7 hours of downtime on whatever you're building. 3 9s, that's 99.9%. Now we're getting into the territory of things that are actually more challenging to hit, because that means 43 minutes of downtime per month maximum. 4 9s is a seriously reliable system with only 4 minutes downtime per month. And 5 9s is considered to be the gold standard, where you only have 25 seconds a month of downtime. Now, usually when someone's promising 5 9s, they're not promising it with a monthly measurement interval, because a 25-second response to fixing a system when it breaks is just not possible. And so they're actually talking about an annual uptime of 5 9s, which is 5 minutes a year when they might be doing their service or failover to a redundant replica that they have. So that's what the 9s mean. Let's try taking apart some actual SLAs and seeing what real providers are promising their users. And so we'll look at cloud VM providers. And we'll look at the top 3 major providers as of today, which are Microsoft Azure, Amazon EC2, and Google Compute Engine. All 3 of them, right at the top of their SLAs, promise 99.95% uptime, or that you only have 22 minutes of downtime per month. That sounds pretty good, because 22 minutes of downtime a month, my home internet connection is more flaky than that. So, maybe I won't even notice if their system goes down that often. Right? Well, the other things they promise is that you're going to have a 1-minute sampling frequency, which means that your system could be down for 59 seconds, be up for a second, down for 59 seconds, up for a second, and be within SLA. That's probably not going to be acceptable to anyone, including them when they're providing service, but that's totally within their SLA. Same with what they count as an outage. If you look at Compute Engine, an outage has to be at least 5 minutes long before they even count it as an outage. Okay, so it doesn't sound quite as good, but still, 22 minutes a month? That's more impressive than I can do on my home computer. So what does this SLA imply for the provider? What is it they have to do in order to meet this 3.5 9s SLA, or 99.95%? Well, that means one of 2 things, and it's actually not made clear in their SLA. Either they've built a really reliable hardware and software stack, and so they expect failures to be incredibly infrequent. And so on average, they're not going to get more than 22 minutes a month of downtime. Or they're promising that when it fails, they can fix it really quickly, and they're fairly confident they can do that. And what do I mean by really quickly? Well, let's say one of their computers in their data centers caught fire. And don't laugh, this actually has been known to happen. And so from the computer catching fire, some of their monitoring systems have to detect that a computer has broken in some way, maybe by being a smoke detector. And then it needs to inform an operator that they need to fix something. So set off a pager or a cell phone or send someone an urgent email. And then that operator has to receive the message, log into the system, debug what's going wrong, bring up a backup, fix it, and get your service back online, your VM back online, all inside of 22 minutes. That takes some serious amounts of caffeine drinking in my experience. And there actually are a lot of professional operators who are very good at this kind of firefighting and this kind of bringing systems back up quickly. But in order to do this, they need to be sitting at or near a computer when the emergency happens in the first place, which means to provide this level of reliability, it implies that you have full-time staff sitting by their computers waiting for emergencies 24 hours a day, 7 days a week, which means you probably have staff either working night shifts or working in multiple time zones around the world. It's a huge investment to get this level of reliability. This also not only puts restrictions on what the provider of the service is doing on your behalf, but it also puts restrictions on you. In order to get this 99.95% guarantee, these SLAs require that you have more than one virtual machine with some sort of load balancing failing over between them, and these virtual machines have to be located in multiple fault domains. You need to have this automatic failover all set up. You need to have monitoring. If you don't notice there's an outage and you don't tell the provider that you noticed an outage, they're not going to do anything about it, and they're just going to pretend it doesn't happen, according to what's written in their SLA. They maybe do better than that if they're trying to emphasize their great customer service. Also, all of these SLAs for all three providers, Microsoft, Google, and Amazon, say that you have to be able to tolerate planned outages. They may tell you about an outage in advance, and you need to come up with some plan for migrating your service away to avoid the planned outage and dealing with it. And also, it's always a good idea that when they have an outage, you should be able to bring up extra machines and bring up another instance of your system elsewhere as quickly as possible, which means you probably want to automate machine provisioning. In particular, the Compute Engine SLA calls this out explicitly. They say it's not considered an outage if they take down your current virtual machines, but give you the ability to bring up new machines very quickly somewhere else. 'Tis what it is. So as long as you have a robust, easy to deploy system, you can make a reliable service on top of this. With all those constraints, you gotta wonder, is the SLA contract or is it marketing? And the answer is yes. When you read these SLAs, the first thing they emphasize is how incredibly reliable whatever service you're buying is provided. 99.95 sounds really hard to achieve, and trust me, it is. But then they have a whole bunch of details which give them all sorts of outs for all the things that can go wrong, because they don't want to have to go to court and be sued for failing to do what you would imagine they might possibly be able to do, but things go wrong. And so because of this, I would argue an SLA is actually both. Very few people go and dig into every single detail of the SLA and cut it apart and figure out, well, what scenarios am I okay in and what scenarios am I going to get hosed? But the nice thing is, if you look at a particular business, in this example, the VM providing business, it's extremely competitive. None of the providers ever wanted to have an outage, and when they do have an outage, they want to make it as painless as possible for their customers, so they work their butts off to make sure that it doesn't hurt them, or it hurts them as little as possible. So far, the industry's track record is they've been very proactive about offering refunds when things go wrong, very proactive about fixing outages as quickly as possible, and very proactive about trying to educate their users about what kind of outages are possible so you can build a robust system on top of these systems and be successful. Note that these SLAs tend to offer credits which make your computing cheaper when you're using their services, but it doesn't cover your business losses. If you're operating a very profitable business on top of a cloud VM provider, you probably need your own insurance policy to deal with an outage causing you trouble. And that insurance policy might take the form of just hedging your bets by spreading your service over multiple service providers on the assumption that hopefully they won't have a correlated outage between them. So let's say you're now an engineer and you're trying to set your own SLO. And note, I'm being careful here. An SLO is not an SLA. You as an engineer can set your objectives, but agreements are often made based on business needs, and that may be set by management or your marketing team. So the first thing as an engineer you should know is that different applications have different requirements, and you need to really know your application. Luckily, most engineers really know what they're doing because that's their job. The other thing you should realize is that setting an SLO is sort of like estimating time to build a piece of software. You're going to be wrong, and you're going to be overly aggressive, and that's just the nature of setting SLOs initially. Most people are just think they can do better than they actually can because they don't think of every single possible thing that could go wrong. And Murphy's Law really does apply when you're talking about uptime. And so you should be conservative. You should take your best guess and then say, oh, I'll knock a 9 off of that, or I'll reduce that and make that less aggressive, because you're going to be wrong as you figure out all the things that possibly can go wrong. As you gain experience, you can then tighten your SLO and make it more aggressive. Also, always take a look at your SLO and make sure that it is always looser than your reaction time. Never promise that you're going to have less than 22 minutes a month downtime in a month If the time it takes between something going wrong, your monitoring system detecting it, your pager going off, and you getting to your computer is greater than 22 minutes. It's not possible for you to meet that SLO if anything goes wrong in that case, and so you shouldn't promise it in the first place. You should also know the SLA of your dependencies. If you're using someone else's computers or depend on someone else's service and they provide an SLA that is loose, then you shouldn't set your SLO to be tighter than their SLA, unless you have some reason to believe that you can keep on working even if they go down. And then the other thing you should do is you should be conservative in bounding your responsibility. Try not to set an SLO that promises things about other people's systems when you don't control the reliability of those other people's systems. Note that this is in stark contrast with one of the fundamental principles of systems design, which is the end-to-end principle. Normally, when we're designing systems, we want to measure the whole system from one end to the other. So from a user's mouse click to a package dropping in someone's mailbox, if you happen to be Amazon.com. And we want to optimize that process to make it as efficient and as painless as possible. But if you're setting an SLO, well, you may not control the postal service. You may not control how reliable your end user's mice are and how well they register mouse clicks. And so you don't want to make promises about those kinds of things and have them built into your SLO if you can help it. So I just want to mention one controversial topic, which is, should you try to exceed your SLO? Now, I say this is controversial. Your first reaction is probably, that's not controversial at all. Of course you should try and exceed your SLO. Who doesn't want to have a system that's more reliable and faster than what I promised to do or what I hope to do, right? And I agree, you should try, but you shouldn't try too hard. Because if you try too hard, that means that you're either wasting time or money on building a system that's more reliable than the goals that you set for yourself in the first place. Also, if you try too hard to make something more reliable, one of the best ways of making something reliable is to build it once and never change it. And if you never change it, you're never improving it. So you're stifling innovation in the name of reliability, which might be good, but often is not actually what you want to do. The other reason why you don't want to exceed your SLO is more subtle, and it's this. You don't want your customers or your engineers who are relying on your system to assume an implied SLA. If you build a system that is only supposed to be semi-reliable by design, but by coincidence it happens to be really reliable for 12 months straight, well, then other engineers may build a system that relies upon yours that assumes your system is really reliable. And if those other engineers are building an important system, and it would be disastrous if their system goes down, well, all of a sudden, they've given you an implicit SLA, which is much stronger and much more robust than you may have designed for or maybe staffed to actually achieve, which is bad news. So that means that in the past, when I've been working on systems which have an SLO that is not that strong, and if they do well, we say, okay, we're going to schedule a regular outage. We're just going to say if we exceed our SLO for too long, we'll just have an outage, make it so that we get back closer to our SLO, remove some of that headroom, and reset our customer expectations. Which is kind of counterintuitive that you'd want to do this, but it can really help when you're negotiating between teams to make sure that they really understand what each team is providing. No discussion of SLAs would be complete without saying how you can go about making your system more robust, taking a bunch of non-robust systems and make them more robust, right? So you want to be able to compose SLAs. So let's say you don't have any redundancy in your system and you're building on top of someone else's system. You know that your system is not going to be more reliable than the things you depend on. And so I've expressed that here as the probability of an outage is always greater than the probability of the dependencies of your system having an outage. Okay, that makes sense and it's easy to wrap your head around. But what if you have redundancy? What if you said, I want to make my system more robust than the things I'm building it out of, and so I'm going to have replicas and I'm going to have failover between them? In that case, if you have built a perfect system, the probability of an outage is going to be greater than the probability of the outage of each replica raised to the power of the number of replicas. Now, This equation which I've given here makes a number of assumptions. It assumes, one, that each of your replicas has independent failure. And that independence assumption may be violated in the most nefarious ways when you go to build a real system. The second assumption that I've made here is that the only thing that will take you down is your dependent systems. And that's why I put a greater than sign there and not an equal sign. Because if your load balancing system goes down, you're out of luck. Your probability of outage will be worse than the combination of the systems you're built on. Also, if your software itself has bugs, and tell me, who can write software that doesn't have any bugs at all? I know I can't. Then you're going to get worse performance than you would expect just based on compounding the systems which are built upon. So you should be aware of this greater than symbol. This is really just setting a bound. You can't be any more reliable than your underlying dependent systems, but you're almost certainly going to be less reliable. And that's another reason why I encourage you to be conservative in what you promise at first, and then gain experience to learn how reliable your system will actually be. So let's conclude. First off, I want to make sure that everyone listening to this video is no longer going to confuse SLI, SLO, and SLA. Don't tell people you've got an SLA when you haven't agreed to consequences. In that case, all you have is an SLO. Second, if you measure it, you can improve it. And that's why you want to set an SLI and SLOs, is so that you can measure your system and make it better. You should always, when setting your SLO, under-promise and over-deliver. And if you over-deliver too much, you should perhaps consider scheduling some outages to back off a little bit and make sure that you don't over-deliver too much. And lastly, nothing beats experience when you're setting an SLO or an SLA. And you're just taking a shot in the dark if you don't have a lot of experience under your belt when you're guessing how reliable you can actually build your system.